Today we're going to be working on lesson 7.4, multiplying binomials with special cases. As always, let's get started by putting your name up on your top row to make sure that nobody else accidentally gets a hold of your material. So the first thing that we see is that we have an instruction, we have a guide, and it says that this quantity of a plus b, when it is squared, you automatically know that the result is going to have this setup of a squared plus 2 times a times b plus b squared. Let's box this because we need to make sure we remember it. We're also going to make a note to ourselves that a plus b quantity squared is the same thing as a plus b times the quantity of a plus b. And if you took the time to do all of the distribution or the FOIL or the box method as we did in the previous lesson, you would find that this pattern of behavior happens whenever you multiply these two quantities together. So conversely, if you have an a plus b pattern, we're going to have an a minus b pattern. So let's write that over to the side. So the quantity a minus b squared is equivalent to a minus b times a minus b. And the quick pattern of behavior to remember is a squared minus, this is where it's different from our other one, 2 times a times b. Just that minus is different, plus b squared. Let's box this up also so that we can find it quickly when you are of need. So the only thing that is different from the one that was typed originally on the page is that this second term is a minus instead of a plus. All right, so let's begin with an example together. Problem number 1. Problem number 1 reads the quantity of a plus 7 squared. And yes, this really is a plus 7 times a plus 7. And if I wanted to take the time, I could do the FOIL, I could do the distribution, I could do the box method, or I could now use my new known pattern of behavior. So my first term, a, always put your terms in parentheses, plus, this is a plus in the middle, so I'm going to use the plus, 2 times a, that's my first term, times b, my second term, which is a positive 7, plus, again using my parentheses, my second term, that's b. In this example, it's a 7 squared. That looks a little bit messy, but as soon as it cleans up, which will be very fast, you'll say, wow, that's it? That's all I had to do? Yeah. So a squared, nothing really appears to happen, so I can drop the parentheses. A squared plus coefficients, multiply to other coefficients. 2 times 7 is 14 times a, so 14a, plus 7 squared, 49. And that's it. It's done. Wasn't that easy? All right, so pause the video, take a moment, and you try to do number 2 on your own. I'll give you a hint. We might need to use something that we wrote up at the top of the paper. Hint, hint. Okay, let's go back and look at problem number 3. Problem number 3, I specifically wanted to do this problem because it shows you the value of using these parentheses. Some people think they're really not needed, but here it's really helpful to use them. I have a minus in my binomial. So we're going to use the pattern of behavior that we wrote over at the top of the page, where the only difference is that my second term ends up being a negative instead of a positive. So using my parentheses, I have 3d in parentheses squared minus 2 times parentheses 3d, that's my first term, times my second term in parentheses, plus my second term of 5 squared. If we had not used the parentheses, I'd guarantee you'd forget to square the 3. It's just what happens. Those parentheses remind you that 3 is turning into a 9d squared because the 3 was squared and the d was squared. That's super important. Minus 2 times 3, 6. 6 times 5, 30. D plus 25. And that is your final answer. So there you go. That wasn't too bad. We just really needed to take a moment and look at the power of clarity of what those parentheses do for you. Let's go look at number 10 together. I don't know why it jumps from 3 to 10. You're welcome. It just does. On problem number 10, we are instructed to find an expression for the area of each shaded region. Underline shaded, because that's what your goal is, to go find. I need the shaded region. And then we're going to write our answers in standard form. Okay, so the shaded region, that comes from let's write this. Your shaded region comes from the big square, the whole thing of the big square, minus your small square. This problem is really important. I will guarantee it will be on the state exam. It might not be with the polynomials and the binomials, although the likelihood is very high. But I will guarantee there will be problems with shaded and unshaded. Go find the difference between them. So let's make sure that this is a solid skill that you will have. So the shaded is the difference between the big one and the small one. So why don't we go find the total area of the big square first. Then we will find the total area of the small square, and then we'll subtract them and simplify, combine like terms. So the big square, length times width, is going to be x plus 8 quantity squared. And we've just seen from example number 1 that we can use our new pattern of behavior for today to help us out. Let's write it at the top. A plus b squared equals a squared plus 2ab plus b squared. There's my reminder. It's good to have a reminder. Okay. A is my first term. My first term is x. X squared plus 2 times my first term times my second term plus my second term squared. Did you use your parentheses? I sure hope so. You can never go wrong with parentheses. They're your friend. All right, so x squared plus 2 times 8, 16. X plus 64. So this is my big. We're going to use that, although it's not my final answer. We're boxing it up so we don't lose it. Let's go find my small. Again, my small square is length times width, but here both of my dimensions are in x. So it's just x squared. Done with the small. Don't you love it when they finish up that fast? Okay, we said our shaded is going to come from the difference of the big minus the small. So let's just finish this up. My shaded will be my purple polynomial. Say that 4 times fast. Purple polynomial. X squared plus 16x plus 64 minus my small polynomial of x squared. Combine like terms. X squared goes with x squared. And hey, look, that one's positive, that one's negative. They're going to cancel out. So my shaded region ends up being just 16x plus 64. Final answer. That wasn't too bad. We found the area of the total big one, length times width. I found the area of the little one, length times width, and then just subtracted. Okay, it's your turn. You get to do number 11, so stop the video and try it out. If you're stuck or if you get an answer, come and ask me. Welcome back. Let's look at number 12 together. Word problems, your favorite, I know. A flat square roof needs a square patch in the corner to seal a leak. The side length of the roof is the quantity x plus 12. I bet that's going to be important. Let's underline that part of the sentence. The side length of the roof is x plus 12. And the side length of the patch, I bet that's important, is just x. What is the area for the good part of the roof? Well, let's see. The total roof minus the patch, it means that the rest of it is the good part of the roof. So let's write that down. So good equals the total minus the patch. That looks kind of familiar, doesn't it? Like the example we did on number 10. Great. So this should be pretty easy. So let's go find our total. The side length of the total of the roof. What did we say the side length of the roof is? Oh yeah, it's x plus 12. And I know that this roof is in the shape of a square, on a square roof with a square patch. So how do you find the area of a square? That's right, length times width. So that means our total x squared plus 2 times x times 12 plus 12 squared. Okay. So my total is going to be x squared plus 2 times 12 is 24, x plus 12 squared. Do you remember? Good job. 144. All right, there's the total area of my whole roof. Let's go find out about this patch. So what did we underline about the side length for the patch? Oh yeah, it just is X. And we know that that patch is also a square. So the area of the square will be X squared. I love simple problems. They make me happy. Oops. Okay, let's go find out how much of this roof is any good. So we're going to find the good part. Which is your total, x squared, plus 24x plus 144, minus your patch that is x squared. And hey, in this one also, we're combining like terms, and when we do that, we see that our x squareds again cancel each other out. That's so nice. Leaving us 24x plus 144. That is the area of the roof that's still in good shape. There you go. All right, there's number 12. It's your turn. So go tackle problem 13. And if you're stuck or if you think you got an answer, come and ask me and pause the video. Let's finish up this handout with problem number 14 together and see if we can find any new special cases, new patterns of behavior. Yeah, these are a little bit different from the other pattern of behavior that we've seen so far in this handout. So when we did the other problems, we had both of the binomials with the same sign in them. Here I don't have that. I have a positive and I have a negative. But being that all three of these problems are like that, I bet there's a special pattern of behavior that they want us to see. So let's look at 14. And we'll do it the long way. We'll do FOIL and see what that does for us. So let's remember what FOIL is. F for first, O for outer, I for inner, and L for last. FOIL. Let's do that process. So multiplying the first two together, S times S, S squared. Outer, so the very first one to the very last one. A positive times a positive, positive. S times 13, 13S. Inner, these two guys right here in the middle. A negative times a positive, it's a negative. 13 times S, 13S. And then last, the last from the first binomial times the last on the second binomial. What's a negative times a positive? Good job. It's going to be a negative. And what is 13 times 13? Do you remember? 169. There it is. Okay, we need to combine like terms and see if something special happens. S squared, nothing to combine. A simple s with another simple s, yeah, these do combine. And check it out, one of them is a positive 13, the other one is a negative 13. That's right, they cancel each other. So we find that we've got s squared minus 169. And you might say, where'd 169 come from? 169 is equivalent to 13 squared. This 13 up there, because it was 13 times 13. So, just for clarity's sake, let's see our new pattern of behavior. New pattern. A plus B times A minus B. Every time you see one of these problems, it goes real fast. Love these problems. It just ends up being A squared minus B squared each and every time. It's so tiny and simple, and that's what we saw in problem number 14. Now I'll give you a hint. With 15 and 16, you better use your parentheses. If you don't, you're going to be having some troubles. So that's the end of this packet. I want you to tackle 15 and 16, see if you can get those done. And as always, come and ask me for help or to check your work.